Howdy do. Good evening, everyone, and welcome to ESP32 Shenanigans. Yeah, and project update and some bits and pieces and catch up and chat and whatever. See you in a few seconds. And catch up and chat and whatever. Okay. Sorry about the interruption from the desktop. Anyway. Well, here we are again. Yeah. So what we've been up to, trying to do a few things. Let's just say hello to someone. How do? All and sundry. All and sundry. That's it. Right then. So yeah. Oh god, here we go. Whatever. I wasted some more money this week. What did I buy? Yeah. I bought a StarTAC. What's it say? USB 2 cable, 2 meter micro USB cable A to down angle micro B. Okay, and if you want one of them, it's a USB A UB2MD. Got it off Amazon. I think it was about 3 or 4 quid or something. Anyway, let's get it out and show you. I bought it because I needed to do something. So, but needless to say, it didn't actually work. But it's one of those things that there's no sizes on the listing for it. So basically, it's standard one end to a cranked, a tight fitting, I thought, cranked micro B. All right. So you might say, what do you want that for? Let me show you. Right, so I've got me a little PCB. Right, this normally sits in some female headers. The ESP32 S node MCU sits in some headers, right? I wonder if you can work out why I want it. Anyway, I've got this is not made up board yet, so I can pull the stuff off. Right, I've got various angles and all sorts, but what I've done is just put some cheap, on the other ones, just some cheap low profile screw terminals, non-pluggable. So these ones are pluggable, right? But I was hoping to get the programming lead in here. I was hoping to get this. Hang on, how do I do this? In there. And you can see it's not going to go. See, it can't go in. No way to get it in. Yeah. It's alright. I hate trying to look in a camera that's revert. Hand-to-eye coordination doesn't work, does it? Anyway, you can see what I was trying to do with that. So that's a bit of a shame, but chocolate fire guard. Anyway, this is where the R&D gets expensive. Research and development. Yeah. Old taxman, if you're watching, I wonder why I'm spending money on stuff. Have a look at the video, you'll soon see why. And to tell you the truth, most of the stuff I buy ends up like that. chocolate fire guard. Yeah. So anyway, so the problem I got, I'm trying to make this a bit more appealing. Now I even thought about taking this off and just buying putting the bits on the boards directly. But I like that at the minute. It's quite low profile, right? But if I was to, hang on, can I show you one? Yeah, hang on. Let's show you. Right, here we go. Here we go. Right, here's my mobile one. I've got a mobile one here. One I made earlier, mobile version, and that's another gadget I can show you. Actually, there's another expenditure there, another £3 or £4, but this one actually works, and that's quite interesting. Actually, that one. Basically, I can plug this into my USB-C into my power brick. Hang on. Into the power brick. To make sure I don't drop this. It's really heavy. It's like holding a brick up. Anyway, that gives you 5 volts. But this little board, you can set. It's got a little chip on it. It negotiates the power or the voltage. I forget what it is. Some PID thing. I don't know. Just special chip. So for the price of them, I spoke about it last time, but the price of them, you might as well just buy that. Set a dip switch for 12 volt, and you just get your 12 volts out, and that feeds into the spaghetti. Into, where does it go? Actually, where does it go? Oh yeah, into these connectors. Anyway, so basically, it's just so you can take it round. Anyway, I'm not going to take it round like that, but I'm going to make it better. But let me try to show you what I'm trying to do. Right. What we're trying to do. Can you see the node MCU? It's in female sockets. And make sure you don't drop something on the keyboard. So it's quite high. It doesn't look too bad, but it doesn't look too good either. Anyway, so it's the same as. Oh, you decide which one looks better. Hang on. Oh God, eye to hand coordination in reverse. What I need is a mirror. A nice 2 mirrors angled to feed back. I can't even do up and down, look. What's going on here? Anyway, so, oh my God. Right. It's alright. My left hand thinks it's the right, and the right thinks it's the left. Oh my God. So much fun this is. Imagine if you didn't have reverse picture, how easy it would be. Anyway. Oh my God. Anyway. Right, so anyway, I like that look rather than this look. But let me put that down. My arms are dropping off. Hang on. Let's put that down. So you got the idea. Right, so you got the idea. So I was about to build this up. Now, basically, as it stands at the minute, I need to flash this before I solder it in, if I want to solder it in. But then I'd have to trim all the legs off. So this is the shenanigans I was talking about in the title. So the shenanigans is, I like the idea of that flush like that. What I should do is buy a castellated one and solder that. But, let me take this out. Right, so if I take this out, never get it back in again. So this is the bit where you need dexterity. Right, so take that out. Now have a look what's underneath there. There's a whole array of chips underneath it. Alright? I'll tell you what, let's go one better. Let's get the USB microscope on the go. Right, let's do that. Right, let me just see. Even that's confusing. The playback because it's delayed. So anyway, cheers. Right. Anyway, it's madness, but yeah, what most stuff is. Right, tangent. Going off on where did I get to? USB microscope, that's it. Right, so I've got a microscope. Here it is. I fancy the idea. Hang on, will that screw? Yeah. I'm going to turn the where are you? Where are you? This Andon Star USB microscope, right? Now it's normally like that, but I want it higher, so I'm going to do something weird with it. I'm going to undo it. I'm going to turn it upside down like that, and I'm going to hook it. Let's make some space. Make some space. I'm going to hook it there like that. Right, it's the wrong way around. Hang on. Right, so will that be? No, I don't know if that's gonna. Yeah, that might do it. So anyway, right, it's not gonna work, is it? Let me just undo that. I've got to do all sorts of juggling going on here. So we're juggling around here. So I'm going to do that. I'm going to put that in that way around like that. It's a good thing about these ones. You can actually mess around with them. Look, you can alter them. So I'm going to put that in there like that. I don't know. It's probably not going to stay still. So I need to move the USB lead. This is a bit of a live going on here. I've got to try and do all this without affecting all sorts of stuff. Alright. Oh my god. ESP32. Life was so much more simpler with an Atmel. Yeah, Atmel. Hang on. Right, I've got to clamp this on here. I don't trust it. So I'm going to use one of these trusty over-the-size clamps. Alright, I'm going to stick this in here. You can't see all this. Maybe I could let you see what I'm doing. Hang on. Yeah. Howdy do, everyone. Welcome to Dave and his mad shenanigans. Totally insane shenanigans going on here. Yeah. Anyway, let's just get that there. Fasten that there. That's nice and sturdy. That's all right. I can live with that. Can you see? Oh yeah. Right. Okay. Okay. So I'll get back to the other view. Actually, that was better, wasn't it, for a minute? So what I've got to do, so I've got a shenanigan of a chair as well. It doesn't roll, or sometimes it rolls, but sometimes you're sitting on it and it'll roll. Anyway, right. So I need a bit of space here. Tell you what, let's get the roaming cam. Did I introduce? Where's my camera down view? I seem to have lost. Yeah, I've lost a view. Got that view. Right. I've lost a view here somewhere. Right. Let's try again then. Or maybe I switched it off. Let's go down the list, see if I can see anything with it switched off. No. Anyway, you'll like this stream. It's an insanity. An insanity stream. Right, so let's... Oh, there it is. It's just not showing up. And is it not showing up because, hang on, maybe it needs, because a reset, deactivate, activate. No? It's not working. Oh, I've got two lots of cameras, that's why. It's in a different socket. That's why. Alright, so it's not there. Oh, that's weird. Well, let's try again. No. Deactivate, activate. That's a good thing about doing an impromptu live stream. Right, so let's pull him out. Maybe he doesn't like. Hang on. Let's pull him out. Right, so I pulled him out. Right, so he doesn't like the socket he's in. Oh my god, I'm actually getting overrun with stuff here. Right, so I plugged it back in. Let's see if it's picked him up. It's not having it, is it? It's not having it. It's got power. Yeah, it's not there. Oh, where am I? Yeah, it's not having that. Okay, let's take it out of there. Alright, out of that one. And plug it back where it was the other day. Will it reach? No, it's not going to reach there. Oh my god. Right, so what I'll do, I'll pull one of the cameras out. Hang on. Where's that one coming from? There, that one. Pull that one out. Let's try it in now that we've pulled another one out. Right, so we've got. Alright, it's not having it, is it? Oh, they're actually lit. The ones that are working are actually lit. Oh, maybe, I don't know. Right, let's cancel. Discard. Right, so tell you what, we'll take it off. Oh no, we won't. We'll leave it on. Right, so go on there. Go like that. Alright, it's not finding it. It seems to have found two for some reason. Ah, we got it. Right, so we got it now. It's got a nice view of my my drink at the minute. So what we want a nice bench view. So we're gonna have to swing this round. All right, let's swing this round. All right, can we swing it round enough? What we're looking at? I don't even know what we're looking at. Let's try that now. I'll tell you what. Let's get it down. Oh, that's as far as it goes down. Oh no, hang on. Hang on. That's it. That's the one. Right, so what we got? We've got a microscope cam being used as a something or other. Ah, is that better? Yeah. That's better. Right, let's go lower. Alright, let's go lower. Let's try and turn the light on. Hang on, light on. Right, so got a light on. We're lower. Oh, let's tighten it up. That's it. Right, we're tightening up. We've got the light, the LED on, full blast. Yeah, we can see some of that. Now we need to spin the camera around. Let's get some for my. Right, so I get some. There's a lot to line it up. Okay, tighten it up there. Okay, so we've got this going on. Yeah. All right. Right, let's move some junk. Let's move a bit of junk. Right. So can we put the PCB down there now? We've got this in the way now. Let's move that all across a bit. So what have we got? Alright, that's too much zoomed out, isn't it? Too far zoomed out. So we can give you a little bit more. If I undo that clamp, do something a little bit strange. Oh my god. Do we even need, we need the clamp. Hang on. Right. Okay, let's give us a few more inches. Okay. So, what we got now? Bit better, not too much better. We're swinging around. Why are we swinging around here? Let's let's tighten that up. Straighten it up. Okay. Focus. Alright, okay. Alright, so I've got. That's it. Right. Oh, I seem to have dropped something in my drink. Oh well. Remember that scene from Penguin? You know, when he comes out of the cellar and he's dying of thirst. Ooh. He goes, I need a cool glass of nice cool glass of ice water. That's what I need. Anyway, let's get that cable out of the way. So we've got the gadget here. So I don't know. So we've got different things going on here. Now I can have different connectors. I had weird ideas. I even thought about putting the connector underneath. Like that. That's crazy. And I even thought about putting this one on, which is I'll take these off and put these ones on. So we end up with something like that. Okay. Which looks like that sideways on. If you put the controller in, get the controller, put the controller in here. Yeah. So I got the controller in. Alright, the torch is rubbish, isn't it? Hang on. Tell you what, let's put some more light on the subject. Right. Is that bad or good? I don't know. Hang on, let's move some of that. I wanted to keep my bench clear, but easier said than done, isn't it? That's not very good, is it? Yeah. Perhaps I need a full screen. Tell you what, let's make it full screen. As much as we can. Right, so we've got full screen. You can't see me now, but that doesn't matter. Let's try and focus it. I wonder if we can get a better... Let's try a better resolution. What we got here? Custom. Is that one really good? No. Top resolution 1600. Oh, okay. Oh, I see what it's done. Hang on. Oh my god. Oh dear. What the hell? What's going on here? I'll tell you what, we need a new scene, don't we? What about this one? Hang on. Yeah, let's try this one. Okay. Right, this lighting's really crap. Hang on. Yeah, it's the lighting, isn't it? I might be better to bring it over here. Or is that better? Yeah. I don't know. I don't know what's better and what isn't better. Right, so I've got this one. Still got the flux on it. So what I'm trying to do, hang on. See how nice low profile it looks with the board straight on the, straight like that. Then you got all the legs sticking out and nobody wants to trim the legs off. So the alternative is to lift it up. I could put it higher. Now it still can't get the socket in. See that there? Hang on, the lighting is rubbish, isn't it? What about if I had a light in that way, like that? Is that better? No, that's not good. Alright, hang on, I got an intro. Right, sorry. Where's my head gone? Yeah. Anyway, I'll quickly tell you what it is.
Beautiful cook.
Alright. Hold on a second. Alright. Howdy do. Right, I've actually reduced my new area here to a mess now. I didn't want to go down that route. Anyway, so we've got this board, and I'm trying to populate it. So we've got the relay that goes on here. Push button. And even when that sticking up a bit, I still can't get the connector in. So, yeah, I need to be able to program it. Hang on, let's go back onto, what about this one? Yeah, I need to be able to program it while it's. I want to solder it in. I don't want to use a connector. I just want to solder it straight in. Well, when I'm testing it, I want to be able to take it out. Right, let's try and plug this lead in. This new lead I got. I can't plug it in. Let's see. So let's plug it in while it's out. Right, so it's in while it's out. And it still won't go in. No, it won't go in. See? Hang on. Yeah, you can't get it in. Can't get it in with that connector on. With that, so you can't do it. Right, so you can't do it that way. So, all right, let's lose that. Let's lose that. Lose that. Yeah. So anyway, I can't get it in. All I want to do is plug that in like that, and drop that into there. So that fits into there, like that way around. Hang on, wrong way around. So drop that into there and program it up. But I can't get it in because the connector's in the way. And I got the lowest profile one I could get. So unless somebody knows otherwise, so right. Anyway, so that's dilemma one. All right. So shenanigan number one. So I'm gonna go back to the original idea. Let's put this lead away. So yeah. Now the original idea is to mount it on. Hang on, let's see if I've got any left over. Let's have a look. Yeah. On there. What about up there? Let's have a look here. Alright. There's my tray of bits. Right. Got a tray of goodies. Tray of goodies, right? Not a pizza box, it's a right, here's the normal connect. The normal connectors I use are these little things that you can't unplug. You have to wire them. And then I've got these male to female sockets that stand too high. Right, PCBs everywhere and buttons. Oh, look what I got. Look what I found. A load of, it looks so small compared to the ESP32. A load of 8266s. Right, where did I get to? Right, I'm just trying to find some standoffs. Oh my god, I just found a load of LED. Just found a load of OLEDs. I forgot I bought a few of them. Why did I buy so many of them? I must be going mad. I bought about 10 of them or 5. How many got? 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. So I must have bought 10 of them. OLEDs, but I haven't got any use for them really. No. Know why I bought them then. What was I thinking? Right, okay. Let's put that away a minute. So we've got these strips of male to female. And let's just lose the... just can't really see what's going on here. Yeah. Anyway, right, so I've got... I can break them and stand it off, but it looks horrible, but it does clear the connector then. Let's do that. Let's make some... get some cutters. Right, so I'm going to trim these down. So it's for this thing. So, alright, that'll give me an idea. So you always got to cut the cut between one of them and sand it down. Right, here we go. Hang on, let's give you the other view. It's probably better than the view I got here is not good. Hang on. Oh, that's in the way now. Hang on. Right, so we're on this view now. Got loads of views, crazy. So we're going to cut this down here. Alright, so I'm about to cut that. You can't see it. Everything I try to do, my hand gets in the way. Right, I've just cut it. And always one drops on the floor. When you cut it, you get the little piece that drops down. I found it. There it is. Just be careful then. Right. Anyway, so you've cut it like that. Cut it down. We need another one. Let's cut another one. Let's cut another one. Actually, there's only one to cut off there. Right, okay. Let's cut another one. We got some more bits fell off. So we've got 2 connectors. Where am I looking? Showing you the wrong one. Hang on. So we've got 2 of these cut. We've got a nice end on one side and a rough end on the other. So we need to... I've got a little sanding belt which I use for that. And I just buffer them up. But what I'll do for now, I'll just trim the plastic back. Yeah, you can't see. Hang on. So I'm just trimming the plastic back. Don't go too tight because it'll It'll be a problem. It'll fall apart. Alright. What I normally do is buy, if I know what I need, I buy them the right size. But anyway, they're still too big. They're still too big, right? How am I going to show you this? Let's see if I can get it back on here again. Let's get back on here. Right, you can't see my face now. What about this one? Yeah. Oh my god. Anyway, let's get rid of the bits before they drop into something short out. Put them in the bin. There's already bits everywhere. Oh well. Right. So we've got we've got this again. So we can either drop them in. We've got to drop these in there. So I can either drop them in like that. I'll tidy them up. I won't solder them. I'll tidy them up. So this thing's gonna drop. So you can't even see that, can you? So what I need is an arm for this device. Sometimes the view we got is no good. Let's have a look. Yeah, sometimes you need to go mobile. Alright, I need to go mobile, yeah. Mobile cam. Alright, so we go mobile cam and we need to focus it. Oh my god. Oh god, what's happening? What am I doing? That's even worse, isn't it? Oh, this is very C6 stuff, isn't it? Sorry. C6 stuff. Right. C6 stuff. Yeah, this is a microscope. It's got a very small amount of focus range. Not the best camera for this kind of stuff. Anyway, so I've got these two female posts. And hardly any light. Hang on, let's get some light on. Right, so a bit more light. Alright, okay, this is crazy. Right, so I've got the two posts, can hardly see. More light, thicker. Right, that's all the light I got. So I'm going to put the ESP32. I got shaky cam. That's the idea, but that is one I did earlier. This is a working one. And you just got, you can see just enough room. Hang on, just turn this silly light up. Shaky cam. Let's turn that light off. Just makes it get red hot. That light does. Right, shaky cam. This is crazy. Crazy. Upside down cam now. Hang on. Right. Okay. So, hang on. Yeah, so. No, it's not working, is it? Let's stop that. That ain't working. That ain't working. We don't want to. Yeah, it's not going to work. Yeah, not everything I do is altogether sane. Yeah. Right. It's supposed to be. Hang on, let's turn the light off. Right, so we've got some work to do. So, project update. We've got some work to do. Nothing to do with the project. in order to get this to work out right. So I've got a camera, a DSLR camera with a nice zoom lens on it. I've got an HDMI capture device. So I could set up the camera on a tripod and do what Chris Edwards Restoration does. He zooms in. He zooms it in when he's doing his computers. Right. So anyway, right. So I've got so many angles going on at the minute. Down here. Not that one. Let's close that one. Alright, that one. Down here, I've got the gadget. And in order for it to be used standalone without an NTP server, so it's not getting its time off the network, it's working standalone, there is no network in its little world, so I've got a little precision real-time clock here, and it's plugged into the LCD stroke I2C port. You could actually stand it up like that. You could stand it up there and plug it in, but it's on a flying lead. You might not need it. So I already use this. Let me find it. Right, so what we got here? Right, here's one of the Arduino Mega versions of it, which is got more capability. This one, it's got two outputs, two relay outputs. It's got two readers, and it's got an RS485 capability, half duplex, plug-in Wi-Fi module, and it's got a precision real-time clock sandwiched in between. Okay. So I think this looks like a half-built one. I don't know. Anyway, so the code is in the firmware already to take the clock, to use the precision real-time clock as the timekeeper. Okay. So so what I want to do is leverage that code. Obviously, it does a conditional compile at the minute. To if it's an Arduino Mega, it falls back onto that. But now with ESP32, it's going to get the network time and use that once it's joined a network. But when you don't join a network, let me show you what happens when you don't join a network. Well, you know what happens. On here, it's joined the network, it's in station mode, and it's got the date and time. Okay. So what I need to do is to be able to use it as a standalone, is get it to take its date and time off this. I've already had a quick look. Apparently this is completely compatible with ESP32. You can use it on that as well with the same code. It uses the wire library. I think in a combination with what it tells you here. Where is it? This Adafruit RTC lib. You can use it. At the minute, it's in there, but it's not doing anything with it. So what I need is I need to create a new class for the firmware, a management class. Because at the minute it started off using this one on the Arduino Mega. If I go to the top of these platform IO in here, you'll see the one for the Mega AT Mega 2560. And it's using, there's only one library there, that's for the time, and it's well, you've got a time library, and you've also got where is it? Did I change the time library? It's not there, is it? Oh, that's weird. I've not tried to compile this for a while. I suppose I should. Yes, you've got an OLED driver there. FRAM SPI, because they've both got FRAM on board, the same FRAM. Adafruit FRAM thing. We've got an extension for an I/O extender. Not using it, but we've got the library there because that's the way it works with my inputs. I've got additional library. We've got some libraries there. We're not using them at the minute, but they can be. Liquid crystal. So we're using this poor Stoffrigen time library. So does that do an RTC? It's alright. I can't. I thought I was using RTC, but anyway, I'll tell you what I'm going to do. Let's switch over to that one. Right, let's go to Arduino Mega. Let's see if we can still compile. Not tried to compile this for a while. I've been concentrating on the ESP32. So anyway, that's what I'm trying to do at the minute. Just give them another option to plug in a real-time clock, precision real-time clock, instead of not having any time at all, which is what you get on here. If I put this into access point mode, I can't show you because I'm using the connection to stream with, so I can't show you. Unless I was, well, I can't do it mid-flow. Swap over from Wi-Fi to Ethernet. So I'll do it for next time. But that will show you 1st of January, and it would 22. It'd go to 22 because that's when I last adjusted the code for that. Right, so we've swapped over to that. Let's see if it will compile. It should do, but I've done a lot of changes. Right, define but not use. Yeah, it's already coming up with errors. Yeah. Elegant OTA. Yeah, we don't want. Lots of errors. Anyway, I'll sort that out for next time. So we'll go back. Forget about that for now. We'll go back to the one we're working on. I still need to use that. I've got a lot of boards here, mostly stuff built with that. So I even got one out on site. Yeah, so we'll sort that out. But I need to basically I need a management class to manage the difference. I need to give everything an option to get the time. So the ESP needs to go through a sequence or a state machine, whatever you want to call it, to try and get the time. It makes no sense for it to try to connect to an NTP server if it's not in a station mode. It's standalone. It ain't gonna be connecting. It ain't gonna be getting an NTP time. So I've introduced a new build flag. Hang on, where is it? Let's go down here. This is where it gets a bit complicated. We've got too many controllers on the go. Right, here we are. Node MCU, that's the one. Right, so I've got a new build flag. I don't know if I needed this build flag, but it's called try use precision real-time clock on ESP32. Well, ESP. So Now, in the main software, I've got an entry anyway. So if I load up, let's go on to that one. So I've already got an entry for
Welcome to UPAS.
real-time clock.
Engine 23 is now online.
In as hardware. So if I go on to here, right, hardware has real-time clock. See, I've got a flag already there in the parameters, but it defaults to being yes because all my Arduino Megas add one anyway. They all add them, but I'm not utilizing that. But as a default, I could set that as default no. Yeah, some defaults need changing. So we create a new device. It needs to be not has a RS485 bus. That used to be no. But I'm not using them anyway, so it didn't really matter. It's just a way so you could tell switch it off if it was causing an issue, you could switch it off. SPI FRAM, I2C FRAM. So that they've all got SPI FRAM. Not all of them have got a real-time clock, but I don't know whether would it matter. I suppose you could try and use it. If it didn't use it, it could just set the flag anyway. I don't know. Or we manually go into the default settings and change it to no. And you have to physically come here and switch it on and save it. That's the way I should do it, really. But what I didn't want to do is compile, build the controller, build each one of these, and then have to go and set a load of settings. I want it to default to working out not in the normal way. That's what we're after doing. Right. Let's have a sip of this. Oh, that's better. Good old drink. Anyway, so this is a real parameter in the system as a real-time clock. So let's just close that down. Let's get rid of this. Let's find it in the firmware, the other end of it.
Thank you for using UPAS.
Let's find it in the firmware. It's so I'll go to parameters. Have a look at load param. We'll just have a look at load. Actually, we'll go to engine. Let's go to engine. Right, here we go. Engine struct, is that the one? No, I don't think it is it? No, it's not that bit. No, it's actually in here. Right, so we've got to... Let's go to the load one. So in here, you got config param. This is a get config param. So it'll load it from the EEPROM. So here we go. Has a real-time clock. It's defaulting to be false there for some reason. Right, so yeah. I think false was something else. So get setting. So right, settings and so we can either use the one we've already got. I suppose that makes sense. But I've only got yeah. I don't know. Anyway, so we've got a try and use that. I started on it the other day. There's so many of these now, I forget where half the stuff is. It's in display, I think it is. No. Yeah, I forgot where it all is now. Dual timer. Is it in the dual timer? No. Film. Dual timer. No. Time zone. I forget where I put her stuff now. You know, put it everywhere. Oh dear. You caught me on a bad day. Right, if you can't find it, go back to main. Go back to main and start again. Right, start from there. Right, here it is. In my setup, I've got initialize the real-time clock. Now, there's no compiler clause there, but when you go into it, why does it do that? Tell it to go there. Go to... Here it is. Oh, that's the header. Right, so we go into there. So initialize the real-time clock. Here it is. But actually, it's not even in initialize. It's just in the library. I'll put this extra bit in here. If try use precision real-time clock on ESP is 1, so it's just a flag. Then it'll include these libraries still. What was happening? They weren't being... I was only including this library, and I was only including those libraries if it was an Arduino Mega, like down here. Right, so I need to... Need to have a drink and go to sleep. Oh dear, it's only early. It's a cruel life because you have to do a day job. You come home and you've basically done your work, and you've mentally exhausted and all the rest of it. It's hard to get back on track, and doing a live stream as well adds a little bit more to it. So anyway, how long have we been going? Let's have a look. An hour, and we haven't accomplished anything. Nothing. Right, let's accomplish something today at least, right? So I can try and make this ESP32 compile the wire library, but the way the Arduino Mega does it, it polls the wire library. We go back to main here. You go down here. If you go down to the loop, you'll see. Where is it? See, displays update. I put it into displays update. So we go to displays update. It's gonna do. This is some old code going back, but it still does everything about the display. Right. So LCD update the display. Then it does an OLED update. Then it checks the time zone. Checks the daylight saving. What else does it do? Every second it'll update the LCD display. Sorry, the device status. And it'll check if the backlight is on. And that's... Yeah, so basically... Sorry, I can't remember where it does the clock bit now. OLED device status, right. Checks the time zone. Update. I think it's done in the display. Yeah, so let's go to there. Go to the LCD update. So here it'll do update device and update the time. Let's go to that one. So the time is it's going to get the day. Alright, so if you go to get day, depends on what it is. If it's an ESP32, it'll do this ESP RTC get day. If it's an Arduino, it'll do is the RTC now. The RTC now. So who's that RTC now? I thought. Let me find. I want to just find out where that is. Go to definition. Right. Time definitions. Right. Okay. Whose library is this then? Or is it just, I don't know, is it the time? Paul Stroganoff's time? Stroganoff. It's not Stroganoff, is it? Who made this? So it's using examples from the library. So it's a time library. So, where, let me have a look. So we've got time library, have we? Where is it? RTC library. ESP time. Is it part of the time library? Oh, Paul Stroffregion. Time. But I don't know if that's his library. Now I can't find it again. Scrolled up the screen. Right. Time zone, time. LCD, is that part of it? Yeah. So, so we're getting the day, and then it works out where it's getting it from. So what I need to do then is go to the bit that synchronizes the clock. I didn't want to use. You got to decide which one you're going to use to sync. You know, to keep the clock going. So it's using get day, and it chooses which one it wants to get it from. All right. So at the minute it's using the ESP's artist, whatever that one is. Time. That's another library again. So it does the same all the way down every time. But there should be one where it synchronizes the clock or sets the clock somewhere. Now, where is that? Alright, so it's... Oh, this is the temperature bit, innit? Get the temperature. Oh, RTC adjust. Yeah, so if it's not running, it'll set the time to the system date time. Oh, this is the temperature. This is how to get the temperature. Yeah. We actually get the temperature from the real precision real-time clock. So that's, yeah, we could do with doing that still, get the temperature, because we do have the temperature. We're not using it at the minute, we could do with that. So that's one good way of making sure that the library's working to get that temperature back. So we've got it there, but obviously we're not, when we're not an Arduino Meg, we're an ESP32. So yeah, we're in this bit here. Set time. I'm setting the temperature to 0 because I'm saying it hasn't got, if it ever asks for the temperature, just reports as 0. But what we need to do is, if we've got a precision real-time clock plugged in, then we need to do this bit here. Yeah, we need to adjust, we need to do all this again, basically. So I could either duplicate that or I could put a clause in. I can't do no. If I've already chosen it here, so I'd have to reproduce that. Do you know what? for now. I know it's inefficient, but for now I'll do that. The problem I got is it could actually break a working system in the interim. So initialize the real-time clock there, set time. That's the ESP32. Alright, let's just see what that's doing. Set time. Peak the definition. RTC, it's actually setting the time to some arbitrary, yeah, going back to 2022. I could update that now. That's probably the last time I ever looked at it. So it would just default to January. So they're going right back to 1970 epoch. Right. Okay, so right. I mean, I've got no problem with. I want to keep it on that side of it. I've got to believe that this newer software is better than the older one. But all I want to do is get the time. So I want to be able to read it. So we need to do initialize. So we need to just put a clause in here. So we set the time. So we're just setting the time anyway, even though. But the NTP site, if it's NTP, it'll adjust the time after. So let's put that in there. Let's just put a clause in. Right, let's just put a if. Right, so let's put an if. Oh, lost it. Where's it gone? Here it is. So we want a clause in here. And we said it was, I can never remember the name of anything. We said it was try use RT, this one. It's a long-winded name, but yeah. Right, so if try use precision real-time clock on an ESP, then do this bit. Right. Okay, so we'll try that. Yeah, we'll put that in there, so that's okay. And we've initialized. We've got to go back and we've done the initialize bit. Anyway, so all we want to do is set the clock. Begin the RTC. If RTC is running, yeah, set the time. Okay, so we've done that. The temperature, we could do with the temperature now, actually. So we need to do another one of these. Alright, so instead of returning 0, we will do a bit of a thing in here. So hash elif, and then hash end. Right, so we're going to move that to there. If there's no real-time clock, it's just going to return the 0. Otherwise, it's going to return the temperature. And it needs to include this get temperature. So I need to, yeah, we need to bring that down. Right, yeah, we need to include that in here. Yeah, we need to put that there. Right, so get temperature, set time. Right, okay, so we need to put that in here somewhere. Right, so let's just put them functions there. And we need to get temperature. Oh, this is get temperature, sorry. That routine is get temperature, so yeah, we need to, okay, we need to lose, that needs to go over to here. If it's got one, we need to get the temperature. We need to lose this. No, get temperature needs to be after this though. It needs to be after them too. Otherwise, we've got to start telling it where it is. Right. So yeah, okay. So we've got. Yeah, that's a bit of duplicate code, which we should never do duplicate code really, but I'm going to leave this to be optimized later, or is that even a good idea? I should do it now. I'll do it later. Not later as in later today, later as in the future when we come to optimize it. Or should you tackle it straight on now? Anyway, so you get a temperature. If it's got one of them, it'll try and get the temperature. Otherwise, it'll return that. That's okay. So it's got this initial bit here. That's it. It didn't need to include this unless it's got it. So what we'll do is we'll put that there. That's already part of that, so we'll lose that. Okay, so press the wrong button then. Hang on. Oh, did it anyway. Right, press it in. Okay, so we've moved that over. It'll only compile these. These will only exist if we're telling it it's got one of them, so that's okay. And that'll only do this bit. Yeah, it'll only do that bit if it's that, otherwise it'll just return a 0. Right, okay. Okay, so that's that bit. So the set time is being initialized. Oh, set time. So that just, you're using set time here. Okay. Right. So when it's initialized, it does this and it sets the time. RTC begin. Oh, this is my new bit. Yes, it'll always do the set time. Okay. So it does the set time, then it adjusts. So basically, what it needs to do, it needs to, when it does set time, it needs to take it from the RTC. So just putting an arbitrary value in. Yeah, that's right. So that's what we need to do. We need to set time with the time it is. So we're doing set time first, and then we're initializing that. So we don't need to do the set time there. we could try this first. Real-time clock, begin. RTC is running. See, we just want to open the RTC up, get the time, then close it down. Right. Let's we'll leave it running. See what happens. So set time. So we need to move this to after that. Right. And when we set time, so I should be able to do an RTC dot something or other to set the time. Get date time. Right, so the get day, month, year, hour, get hour. Right. Let's just have a look at that a minute. Get hour, right. So we need to force it to get this bit. But all I gotta do is set it. Yeah. Right. So I need to set the time. So that must be, yeah, hour, minute. Sorry. Hour, minute, second, day, month, year, something like that. Right. So we're going to set the time. Instead of setting it to that value, we're going to do it from this bit. RTC begin. Right, so let's get minute. Peak the definition of minute. Oh, so it gets an RTC now. Yeah, so we need this. We need that. Okay, so we need that. So we're going to go down to this, and where it says set time, we need another little bit here. So let's just paste that in there a minute. So we need to do this. So we'll have a fail. So hash elif, and then a hash elif. Right. So we're going to put this back in here. Set it to something if it hasn't got a real-time clock. Right, and then we're going to set it. We're going to do this here. Right, so we're going to set the time. I just need to know peak the definition. SC seconds, minute, hour. That's a weird way of doing it, isn't it? Month, day, month, year. Okay, second, minute, hour. Right, fair play. Okay, we can do that. Day, month, year. That's right. So I'll just get it directly. seconds, minute, hour. So there's your minute. Okay. So what seconds? Second. I want hour. We want to set this as well, which is the day. Day. And we want the month. Day. Month. Day, month. I want the year. I don't know if this year. RTC year. Right, let's try that. See if that'll work. It might return just the year without right value, you know, just the 2 digits. Right, so we've got that one, and that's all we need to do. Alright. Okay, so we've got that. We're going to set the time from the precision real-time clock. If the precision real-time clock has never been set, which it probably hasn't, it's a brand new one, it's going to set it to the system date time, hopefully, or the compile date time at least. Right. Let's see if it'll compile. Possibly a library. Let's just try it. Might be a library not enabled or something. It might not like it. We'll give it a go. Oh, well, that's compiling. I'll have a sip. Got no watches. Never mind. What I should have done is shared it out first. But there's nothing to see really. It's just me doing a bit of also, you know, doing a bit. That's all it is. I suppose I could build and test that new one. Right, so here's our first error. Right, C was not declared in this scope. Right, okay, I squared C address. Yeah, so the address is going to be the same, so I haven't adjusted it. Right, so we need to go to whichever does let's have a look here. Is it here? Yeah, it's got some stuff going on here. Yeah, here it is. So we need to do another bit of that same code. Yeah, we need to just alter that slightly. We need to put this in over here. Right, ESP32. Oh, what's happened here? Right. So, yes, we need to include all this. Yeah, we just need to put that in there. Right, and that's it. Extern, right, so we need to find that. I need to make sure that is the same, is being used up here. Right, here we go. Oh, we've already done it. Right, let's try compiling again. Howdy doody. I've turned the audio down a little bit today because I was getting some feedback. A bit of feedback with the speakers and mics, so I've turned it down a little bit. Bit of howling going on. Just gonna have a listen to the audio a second. Getting some feedback. Bit of feedback with the speakers and mics, so I've turned it down a little bit. Bit of howl. Yeah, seems okay. Right. It'll be interesting if we can get this clock, precision real-time clock. It's another option to have it as a standalone with a real-time clock. So I got all your stuff. I don't have to buy nothing. We've already got it for the old Arduino Mega setup. So it shouldn't take too. The only thing we will have. I don't think it doesn't poll it, the RTC. I think it only looks if you do date time now. I think it gets just talks to it. So there's no real overhead other than just the main initialization of it. We could probably get that back by losing the NTP code. So if it's on a access point, we don't need to initialize NTP code. And if it's on standalone, if it's on network, we can initialize that, but don't initialize this other code. So it needs to be a toggle, really, doesn't it? It needs to be done basically if it's on access point or station. Maybe I can alter the criteria there. Because initially I want it to be station and access point at the same time, and it causes problems. Alright, tired today. What we got here? Oh, here's one of my, oh you can't see it, Arduino Mega boards, half built. Is this the new one? Yeah, this is the newer one. Oh, yeah, put all the little bits on, ready. Shame, isn't it? I want to carry on building them up. Shame that. To finish them off one point. That's what happens if you go on to keep moving from one control to the other. Arduino Mega, ESP8266, ESP32, and then everything gets left behind. You just keep on with the main. I suppose that's what you have to do. But I used to like that Mega and what I'd done with it, so I used to like that. Yeah. Oh well. Well, got to get rid of all this stock at some point. Right, so it's still compiling away. It's not complaining too much. Once the time's set, it doesn't need to refer to the real-time clock again, really. Unless the only other reason. Still going to make a management class though, because I need to decide when and where to. What's that say? How you art course, something else declared here. You art set pin. What's that? Okay, I don't know what that is. Never noticed that. What's that? You art set. It's not one of my code. It's someone else's. Right, so it's successfully done that. So what I'm going to do now, just make sure the flag is set. It is on. Right, I'm going to upload it. Right, here we go. Let's give you this view. I'm going to upload it to this device here if it still knows where it is. Right, I'm going to just upload it and see what happens. I'll have to do it off camera. Well, not off camera, off the screen. I'll have to show you on the phone, I think. We'll soon know anyway if it gets the real-time clock. I know one problem it'll have is my software. Yeah, I need to talk to it from my software as well. So there's going to be some. My software won't be able to talk to it because it's just not expecting to see a real-time clock. So we'll have to alter that as well. Right. So we're rebooted. Everything looks okay. It's on station mode still. Let's have a look. Yeah, we're on station mode and it's ticking away. It's got the time and date. So let's come out of that. I'm going to force it into access point. So it's gone to access point mode now. It'll do a reboot. It'll reconnect. Might try to look at the real-time clock. It's just froze there, I think. Oh. So it started an access point. Right, so let me get my phone out. It hasn't rebooted, it's stuck. Let me just reboot it now, see what it does. Seems to be stuck. I'll try and connect to it with the phone. Alright, I can see an access point there, so I'll connect to it. In case it's waiting for a connection or something. It should be running the clock there. Maybe it is running the clock, it's just not updating it because I've confused it. Right, I'm going to go over to the browser now. Right, so okay. What's it doing? Station connected. Yes, I am connected. It's not showing me. It's getting confused. Let's reboot. Alright, it's trying to serve me up a pay. I think it's history. I have to clear the browsing data. History, clear the browsing data. Right, so it's alright, it just remembers it as something else. No, it's not finding it. Why is that stuck there? Right. I know what's happening. I've rebooted. It hasn't automatically connected. Let me reconnect it. Keep forgetting about that. So I'm connected. Right. So I'm connected. Yeah. Something wrong with the MAC address or the IP address. Right. So I'm connected. Let's go back over to here. Right, it's served me up a. You can't see that. No. Yeah, it has served me up, but it's done a reset. So it doesn't quite like something or other. Yeah, this is the problem. Sometimes you have to break something. You have to break the code to make a new code. And when you got it working, it works well. The last thing you want to do is break it, but you have to sometimes. Right, so let's get rid of that. I think it'd be better if I could get this precision real-time clock running. In, let me switch back to that's actually crashing it. Right. What mode am I in? Am I in? Yeah, I'm in normal mode now, so we can get back on here. Right, so we're in station mode again. So if I can make the code talk to it, because I've told it it's got a precision real-time clock. That shouldn't matter whether we're in station mode or not. Now I should be able to get a temperature reading on it. Let's try. I won't have to look at the code on the. Oh no, because it's all the code is there to get.
Welcome to UPAS.
All the temperatures there.
Engine 23 is now online.
All the settings are there to get the temperature, but it'll just report it as 0. But it's not getting the temperature because it's probably not communicating with it. Can't remember when was the last time I used one of these precision real-time clocks. Can't remember when the last time I used one of these. Was there a jumper to set or an address? Don't remember. Probably not. Oh, there is. There is some jumpers. Maybe it doesn't see it. Right, so there was a scanner routine I used to run. The best way is to look at one. To see if I've solved any. No, they're all open. Yeah, I've got an existing one here that's so it just used the default address. Unless it's clashing with the OLED. I wouldn't have thought so. Now the OLED's functioning. So right. What I need to do is run a scanner. Now somewhere I have got an I2C scanner. Tell you what, I could try writing to it. But the set clock it hasn't got the routines in there. Hang on. Let's go back to the.
Thank you for using UPAS.
Let's go back to the. Let's find the command to set the time. Right, let's have a look. Oh god, go away. Right. Let's. Right. Sometimes I lose myself in it, so I have to go back to set param. We don't want that. We want get send param date time. No, none of that. Get RTC. Here it is. Right. So get the set RTC. Here it is. Right. So set param, set RTC. Right, so let me just find out where these are going to. Right, so okay, we've got yeah. Right, fair enough. What I need to do, I've got a bit more to do here, haven't I? I've got a bit more shifting around to do. So let's get right, so how's that? Is this the one I was working on earlier? Yeah, no. Is it at the bottom? Can't remember where I put it now. down the bottom. Yeah. Right, here we go. So we want a bit more of this going on up the top. Hopefully it should all be in this library, this C++ file. So we've got that sorted. We're okay there. To get the second, I'm not really interested in getting it from anything other than the main one. So that can stay out. Get minute, no. Get hour, get day, no. Get day of the week. Get the month now, get the year now. Right, set epoch. So the command was get RTC date, get RTC time. Oh, set it, sorry, set it. So, set, so it's not the epoch one. Right, starts from here. So we're setting the date. Right, we're setting the RTC date time directly, but we want to be able to set this one as well, but only if we've got a precision real-time clock attached. So we'll reproduce this over here. Oh, why am I getting it? Don't know why I'm getting it. Then adjusting it. Don't need to do that, but anyway, that's because that was a long time ago, that code. Right, so anyway, we've got that there. So we're going to set the one, and we're going to try and adjust that clock. Yeah, so that's that. And we'll need that again for this time. Oops, all things and thumbs today. Right, so we want to do this one as well. Because basically my software is sending over the data, sending the clock and the time from the system clock. Right, okay, set time, so get time can stay as it is. Right, okay, let's try that. Right. Is there any more? No, I think that's it. Right. So we'll try that. Let's see if it'll work. Alright, I'm just holding the program button in. Can't see it. Right, so that yeah, it'll allow us to send try and adjust the clock. Yeah, because I didn't see it adjust the clock on the RTC one. Display, wasn't it? Right, it's writing now. Let's have a look. Is it down here? No, is it display? Can't remember. Update display. Anyway, let's get back to it. Right, so let's just see what happens. Yeah, because I'm going to stay in station mode while I try it. And if I run up the software, I've sort of got two real-time.
Welcome to UPAS. Engine 23 is now online.
Right. Hopefully, once we've initialized this thing, I'm going to force the time on it. So let's just go here, real-time clock. I'm going to push the time up to it. But if I ask for it, it's going to give me that, but it's got it off the NTP server probably. I'm going to push this up and hopefully it'll write to that clock as well. Right, Temperature's not, no temperature being reported at the minute. I don't know if it's talking to that yet. Right, so probably the best way is to plug it into an Arduino board without a real-time clock on. Or do some diagnostics, or run up some code. That's it. Tell you what, we'll find a sample example. Right, tell you what we'll do. We'll close this down a minute. Let's just get an art. This is why you keep Arduino.
Thank you for using UPAS.
Keep Arduino on your computer just for these occasions where you want to run a simple sketch just to make sure your precision real-time clock is actually functioning. I'll just run up that now. Alright. So what we want is, we should already have the library in here, examples. It's an Adafruit RTC library, I think it is. Although we may not be using it. That's the point. Let's just double check what. Oh, we are using it. Yeah, of course we are. Hang on. Let's just make sure which library we're trying to. Don't do that. Right. So we're using. You got where has it gone? It's not here, is it? There it is. Adafruit's RTC library. So let's find that. Might not be installed on here. Oh, what have I done? Did I actually close it down? No. It's loading a new one now. Right, so you want Adafruit examples. Oh, hang on. We're getting bombed by. Right, so examples. Right, where's the RTC library? Is that it there? Right. RTC library. Custom wire. Alarm. Don't like that. Right, so that's the only one I can see on there. Thought it was an Adafruit library. Wire. Mm. Let's try some of these old libraries. Right, okay. Well, I'll tell you what I could do is, hang on. I've got a scanner somewhere. Let's open it. Let's try and find a scanner. RTC. No, why? Where's it gone? Right. Scanner. I2C scanner. Where is it? Some of these libraries, some of this stuff I haven't looked at for a while. Can't seem to find it. No. Right, hang on. Sketches. Where's the sketches? Alright, can't seem to find it. My Arduino sketches, where are they? Not there. Not there anymore. So it was in here. Never find it. Used to be there as a default to run. Auto connects. No, that's going back a bit, that one. Right, so right, so let me take this off the screen a minute. Right, I'm just trying to find. I got that much stuff. It's hard to find anything. Right, Arduino sketches. Right. Right, Arduino sketch, it's on a different drive. No, it's an I2C scanner. It's got to be there, surely. IS. Where are you? I got one called R2C. What's this one do? Date and time. Oh, that's the yeah. It is compatible with that one, but alright, let's just run it. I don't know. So ESP32, COM3, serial or speed. Serial begin. That's a weird speed, isn't it? Right. Okay. I don't know if this. Let's just try and compile it. I've got an I2C scanner somewhere that scans for anything on I2C bus. So you don't use them for years on end, and then you need them. You could always get it, download it again, I suppose. If you're wondering what all the music stuff is in the background, it's because it was a little home recording studio, and I ended up I kept it clear for ages just for doing home recording studio. But then I've put the streaming setup in here. Try and make one room into two. So it's, I wasn't using it, so I was too involved with all the programming ESPs and UPAS projects to get any music done. Chain. Maybe one day. So anyway, I amalgamated it two together at the minute. Yeah. What's this doing? Still compiling? Yeah. 2 hours. No drop frames. 32% of the CPU in use. It's only 30 frames a second. That's enough. Okay. What's it doing? Is it doing anything? Oh, it's finished compiling. Right, let's upload it then. Don't ask me what it's going to do. I don't know. Right, here we go. Right, upload it. It's going to wipe out, but at least we can wipe out the firmware. Doesn't matter. And I'll see it. Make sure this real-time clock's working. to start with. What's it doing now? Need to wind it up a bit. Need to go wind it, to wind the speed up. Fatal error. Ah, couldn't connect to come through because Visual Studio Code still got hold of it. That's why. Right, let's try again. Here we go. Righty, I'll try again. Hey, when it takes 2 hours to do hardly anything, you can see where it took 10 years to go from nothing to UPAS. Yeah, takes a long time. It'd probably take longer than a lifespan. That's the problem. Cosmic shame. Right, it's writing, so let that write. We'll have a look. Alright, didn't take long. So, alright, let's have a look. Yeah, what's it saying? Right, saying summit. What's it saying? Didn't say it didn't find anything. And it didn't say the RTC is not running. It's got the wrong time on it though. Is it even doing anything? Right, so it's set it to... No, I should have set it to compile time. That's a bit of a rubbish one, isn't it? This one. Right, so what is this actually telling us? It's the 24th. Okay. That's the time it compiled it. Yeah, so let's set it. Yeah, so it did set the clock, right. I need to go away for a little break now. Toilet break. Too much information, right. I'll put it on an intro. I'll see you in a few minutes. back. Oh yeah, I seem to have a border there. I moved my monitor earlier. And I need to just shrink it down a bit. Come on, that's a little bit. Yeah, that's it. So the little webcam's on top of the monitor. I had to move it to get to the back of the computer. Yeah. Anyway, so where did we get to? Right, so we know. Right, so actually let's go right to the top. Oh no. So it seems to be working. Right. Okay, so let's go back to the other firmware. Let's close that down, shrink that there, right. Let's see if we can. I don't quite know what's going on here, but let's upload the UPAS firmware back on it again. Hang on. Let's get that one there. Right. I've just got it down here. Can't see. Right, it's writing it. I'm tempted to play my guitar. Doesn't take long enough to play. You don't get time anyway. Right. So let's see if we've got a running system. Let's run up UPAS again. Hang on, let's go back onto this one here. Right, we're back on here.
Welcome to UPAS. Engine 23 is now online.
Right. If you didn't know what engine 23 is, that one down there. Right, so I've got no temperature. So it's not reporting a temperature. Now, that might be because the packet's returning a non-temperature. Right. Let's have a look down here. Temperature. Now that's to trigger off a temperature. Yeah. Alright, so let's ask for the settings. So it's brought that. Okay, so it's whatever that is, yeah. Doesn't mean anything. So what we need to do is have a look at command. Right, where's command gone? There it is. Let's go right to the top and have a look at where it's bringing in the packet data, because it's supposed to. What's supposed to happen is it, when it communicates with each controller, instead of just handshaking, it'll ask for the date and time, and also the status here. When you're in drop down mode, it'll ask you for the status. Sorry, when you're like that, it'll ask you for the inputs and outputs. Right, and then when you're down, it'll ask for the time as well as the inputs and outputs. But it'll also ask you for the temperature. So we're not getting the temperature. Let's have a look why we're not getting the temperature. Send engine status. Alright, it's got your timer information, your input, your outputs. Here we go. Yeah, so I'm returning a 0 here. So we need to get temperature here, but only if it's got the extra bit. Yeah, we need to alter the program a bit. I'm trying to do it in a way where I don't break too much code. Right, so what we're going to do is Yeah, it's just setting the least significant bit there, but the get temperature, it's grayed out as well. So, oh yeah, because we're not in that mode. Right. So what I'll do then is I need to introduce get temperature in here. Instead of getting temperature here, it's just returning. Yeah, because we've got to do a bit of this going on in here first. So let's get in here. Else, let's do one. Can you do one within a one? Yeah, we can do one within a one. Right. Okay. Mumbling on. Right. So we want get temperature. Right. We want an elif there, and endif. Right. So what? If it's got an Arduino Mega, get the temperature. Actually, we're gonna, yeah. Else it's not an Mega, it's something else like an ESP. We're gonna get the temperature. If it's got a precision real-time clock, it's gonna get a temperature. If not, it's just gonna return 2 zeros instead. And it's setting your temperature right. So let's give that a go. Let's see if we can just peek that, make sure we got a function for it. Yeah, we have. There it is. We've got two lots of code going on here, the same. So we could have done it from that other bit, or just sent it to here anyway without worrying about that bit. Yeah, we'll leave it as it is for now. Don't want to break any other code. So, right, let's upload that. It'd be nice to get the temperature up again. You got a whole host of things you can do with the temperature. If the temperature gets over range, yeah, I've got temperature setting panel here. Temperature mode, you can set to monitor, trigger an action, or none. Trigger level, set the temperature level before something triggers. An on action, an on number, an off action, an off number. This can be switch another relay on, switch it off, or even run a script, I think. Did I report only? Request a shutdown, request an engineer, none, yeah. So you should be able to run a script as well when something gets over temperature. Anyway, let's get back to this one here. So we're still compiling at the minute. Go away, label. Alright. Okay, so that's compiled and it's writing. So we're going to tidy all this code up. It doesn't make sense. It's too experimental, really, because we're trying to accommodate lots of controllers here. Luckily, most of them are based on ESP32 now. So, right. So let's. We're back on here. Oh, look, we've got temperature. I've got a smile now. That means we haven't wasted the whole night messing around. We've got temperature. So if we've got temperature, it means the precision real-time clock and the communication's working. So let's try again. I'm going to reboot in. I'm going to just change the mode to access point, and it'll reboot. Yeah, it'll lose communication on UPAS now. So I'll just shut that down in a minute. Oh, and
Thank you for using UPAS.
It's rebooted. It's rebooted with the right time. That's good. So I'll get the phone on the go. So that was relatively painless there. Right, let's connect. Yeah, let's just go onto this screen a minute. got the phone up. We've got the controller set up as access point, which it won't be able to get the time off the NTP server. And I've got here, where is it? Can't see it there. The brightness has got you again. But that's the UPAS 98, serial number 3051 23K. So yeah, so I'm connecting that directly now. And it'll show us the time. Tell you what, let me change the brightness down a bit so you'll be able to see it on the screen. Right, I'm just going to get the browser up. Right, we're in. There you go. You can't see, it's blurred, isn't it? Is it blurred? Why is it still blurred? Can't see it. Can you see it now? There, just the date there, look. 16th of Jan, 24, 2219. And MD is his access point. So it's got the time from the real-time clock. Exactly what I wanted to do. Right. Okay. So one more test we can do is I can pull the real-time clock out altogether. Yeah. Right, I'm about to pull the real-time clock off mid-flow. See what happens. Never done that. But it shouldn't be doing anything because it only gets the time. It never doesn't poll it. It sets the ESP32 time from the precision real-time clock. And it never uses it again. But you know, I'm going to put some management into it. Periodically checks it. Right, so that's set. Let's reboot the controller without the precision real-time clock. See if it causes it to hang or crash. It does. So it's stuck there with no time on it. So we need, let me just plug this back in, see what it does. Ready? Plug and play. I don't think it's got plug and play capability, has it? Right, it's plugged in, so reboot. And it should get the, yeah, it's come on now. It's got the time. The only thing is, I want it to fall back. It needs to fall back if, actually, yeah, just give me an idea, because, let's go back on here. Let's go back and see, this is not logged there, it's not there at the minute, so I'll stop that. But I'm not reporting temperature, but we could have temperature on now as well. So that's another thing we've got to do. So I'm going to put this controller back into station mode. And it'll reboot, it'll come back into station mode. 1 beep station mode, 2 beeps access point. Just hold it in for 5 seconds. Right, so we're back on station mode now. Yeah. Okay. Right. Let's go back on that one. Right, so we're on here. So that's a bit of progress. That's alright for today. When you take the precision real-time clock off, what I need now is to make sure if there's not one there, it doesn't hang the system. I don't think it hangs the system, but I think I'm not sure what it does actually. Let's try it. So go back onto, let's have a look. So that's the station mode. We'll switch it back again. Right, so we're on station mode. I'm going to reset, go 2 beeps. Right, that'll reboot and it's switched over to, yes, it's rebooted and we're on, you can see it there, look. It started an access point. Same IP address I use. Right, So it's listening. So the only thing we can do, so it's gone through it. Right, so we know it's working there and the clock is updating, I can see it. So I'm going to pull, it's there, it's working. I'm going to pull off the precision real-time clock, then reboot it and see where we get to. Is it going to hang? I saw an error then. Right, so it's still listening as an access point. It tried to communicate with, so I saw an error. Hang on. Where's that error? Right, here we go. I squared C read, return error 263. Okay. Past OLEDs. Right, so we had an error 263. GPO output number. Yeah, that's okay. Invalid pin selection. That's fine. That's another error. That's not. It actually works, that does. I talked about that last time. That just reports an error as a weird glitch in the system, in the ESP32. Anyway, so we've got. Right, so your wire library has come back with 263. Tried twice and it cancelled. Yeah. Right, so we need to somehow watch out for returned error 263 from the wire library. So after main setup, past init RTC. So during the init of the RTC, it came up with this error. Right, so main setup. Let's go to main. Right, where are you? That's your loop. Init the RTC. So it got past the RTC. Yeah. Got to there. So I think it was main setup was ran, yeah, there. So it's this init the RTC. Why does it come up like that? Go to definition. Why has it done that? Right. So RTC begin. If RTC is running, then adjust it. Right, so I need to find out how we find out if it. Yeah, we need to look into. I'll tell you what, let's ask ChatGPT. Why not? Let's see if it knows. I don't think it will do, but we'll have a look. We'll have a go. Right, let's go on to ChatGPT if he's still awake. Right, how can we help today? Right, good question. Right. Don't even know if it knows this one. Let's see if it knows this library. I'll just paste this in here. Right, let's see if it even knows where this is coming from. Looks like you're working with RTC on an Arduino sketch. Let me explain the code. Yeah, at least it knows. Right, we should have some luck here. We'll be able to get right, so right. How can I tell if the RTC is plugged in? If you want to check whether the RTC module is connected and you can do the following steps. Check the hardware connection. Verify the player. Use an ESP32 scanner. What's this? To use the I2C scanner sketch to detect devices, which is commonly used. Here is an example. Alright, device 0, wire begin, address error equals wire end transmission. If error equals 0, found device at address 0. Oh, address, you gotta choose the address. Oh, doing a for next loop, 1 to 27. Unknown error at address. No I2 is found. Upload this sketch to the Arduino open source monitor. If you are using a specific RTC lake, maybe provide functions to check the status of the RTC. Example, RTC is running function in some libraries can be used to determine if RTC is running, followed by the steps. Right, okay. Right, let's have. Oh, it is. Yeah, he's running. If not, is running. If not, RTC is running. Follow line, set the RTC to set the data. Right. I think that's assuming it's brand new and it's never been set to run. That might not help us in this one. Right, so we need to look at the library. Okay, so I'll use Notepad. Oh, right. What should we use? Yeah, let's use Notepad. We'll open up the library and have a look at it. Oh, we don't need to do that, do we? It's alright. We don't need to do that. We can just go in here. We can go in here. We can just go up to libraries. RTC library, and we can have a look. Right, so have a look in the H. Right, okay, so right, okay. So what have we got here? Function wise. Is valid, month, hour, minute, day, timestamp, operator, time span, pin mode, class, whatever. Where's the functions? Alright, so we've got begin, adjust, lost power, initialized, start, stop is running, returns a number is running. Okay. Enable, calibrate, deconfigure all timers. Don't use the timers on there, right? Right, let's have a look in here. We want the bit that does is running. The bit that does the is running bit. Right, okay. Alright, where are you? He's running. Is this in alphabetical order? Do. Where are you? I think it's time for a guitar. Right. There we do. Right, where are you? Come now. Who wrote all this rubbish? I wonder your ESP32's full up of how many memories are full. Right, what's going on here? Hey, I'm not one for using the search function. Find timestamp. It's very good, but I don't know if I need all this, do I? Anyway, imagine how many other libraries there's loads of stuff in you might not need. It's clever. It's good that they keep putting more stuff in, but that's why you need a bigger memory. Date and time is valid, right? Okay, whatever. Oh my god, where is it? It's not there, is it? I thought I found it once. Where's he gone? He's running. Go to definition. Right, so if it's the RTC is running, read I2C register, return, shifting, yeah. Right, is the whatever running? Check the stop bit in register control 1. 1 if the RTC is running, 0 if it's not. Right. Okay. We could try that, I suppose. Is there another way? Right. So 1 if it's running, 0 if it's not. Okay, let's go back to the code. Adjust. Right, we need to go to the begin bit. Where has it gone? Where are you? Never find anything. Oh my god. Right. So back here. We need to go to initialize, wherever that's gone. Not that one, it displays. LCD update. Oh, hang on, main. Init the RCD. Right, here it is. If not, is running. If it's not running, right, so if it's a 0, the following line sets the RCD date and time this sketch was compiled. Right, fair enough. Trouble is, that's not what we want. Well, no, that's not the right, we don't want that. Right, go back to this one again. Suppose we got check if it exists. Right, so we need to know the address. Right, the address is RTC begin. What's the default address? I don't know what the default address is. Port's busy. Right. So the default address Right, back here. So this should tell me the default address. RTC begin. Right, so there's your address there, which is defined in. It's either defined up here. No. Here. Right, so 068. Right, we'll ask ChatGPT, can you write me a function to check if a I2C device is on certainly below is a simple Arduino function that checks if an I2C device is present at the specified address. Okay. Replace the device address with the I2C address you want to check. In this case, the is I2C device connected function will return true if a device is found at the specified address, or false otherwise. The setup function in this example checks if this I2C device is present at address and prints the result. Upload the sketch. Right, okay. Okay, let's just do that then. Let's do it and see if it does the business. If it does, we'll mod it. Right, so a new thing. New thing. I'm going to paste the code here that ChatGPT's just given us. Right, let's get rid of that. Right, they love 9600, don't they? I don't know why they love 9600. Every sketch has got that in. Right. Okay, so we'll upload that. Let's close the serial port. So we can use it over here. Okay. Oh, it wants to save it. Go on then. Right, so we can do a simple test. We get rid of the print statements after. We'll turn it into a little function. See if it's plugged in. If it's not plugged in, it won't hang D. It will just go back to setting what we did before. Ugh. Oh, it's writing anyway. It's all right. Right, so it's done that. Let's give it a reboot. No device found at the specified address. Right, that's because that is because we haven't plugged it in. So I'm going to plug it in now. To make sure I don't think you can short these out. It's not possible to short them out. So, right. Okay, let's plug it in. I suppose you shouldn't hot plug it really. Right, I'll reboot it. No device found at the specified address. Right, so I didn't find it. So, begs the question why. There you go, let's close it. Oh. Let's close it. Reboot it. Right, open it. Reboot it. Not found. So I didn't find it. So it begs the question why. How do you find? That's weird. What's it done wrong? Oh. Have I got to put my address in? Oh no, just put the address in. Alright. Is device connected? Loop. Right, bool. Right, vibe again. Device address error, wire and transmission. Return error equals 0. Right, that didn't seem to work. Why no? It returns 0 on both states. If the function returns 0 in both states, it's just that there might be an issue with communication or the device not be responding. Verify the wiring, check the device address. Make sure that it's powered and receiving. Check up pull-ups. Use I2C scanner. Right, so there's another. Here's an I2C for reference. Okay, let's put a scanner in then. Right. Okay, we'll put another one in then. A scanner. Okay. Let's try a scanner. I'll try anything once. Weird. Strange stuff, very strange goings on. It's time for a sip. It's time for a sip. Right, it's written it. Oh god, was it written at 9600? Go on then, I'll switch it. Right, okay, hit reboot. No I2C devices found. Alright, didn't find nothing. Unknown error at, yeah. So, didn't find it. Right, so it's not talking to it. Why? I wonder. Tell you what, let's pull the power to it. No, I can't do that. Right, I don't know. I must have blown it up. I thought I had it working. That's weird. Right, anyway. Let's close that. Let's go back to this. Right, so we've already compiled this. Let's send this to the board again. Alright, we're going to program this back up to it and see. That's weird, isn't it? This, mind you, I've never really unplugged them while it was live in the past. Right. See if it's, I don't know, it's one of them, isn't it? One of them, get the guitar out. Right. So, yeah, it's hanging again now. So it's hanging again. Surely I didn't blow it up. Right, okay. Let's go on to serial monitor. So setting up as an access point. Right, let's put it into hang on, it's not getting past that bit, is it? Right, so we're in station mode again. Just going to reboot. Back in station mode. It's got the NTP clock. Let's see if UPAS can find the temperature. If it finds the temperature again.
Welcome to UPAS. Engine 23 is now online.
Yeah, we got temperature. It's weird, isn't it? Right, let's send it the time. Hang on. Script. Set time all engines.
Synchronizing clocks on all engines.
Right. So we've got temperature. I can ask it for the time. Yeah. Okay, so don't know. The temperature's definitely still there. So maybe I destabilized it. Right. Let's give it back into access point mode. It's gone straight in there. See that? It's gone in. The time's come on. And we're in access point mode, yeah. So it's got the time, June. Yeah, that's right, 16th of Jan, sorry, it's not June. Right, so that's
Engine 23 is offline. All engines are now offline.
So I'll run this sketch again. We'll run the scanner sketch again, right. So let me close down the terminal. And we'll upload the scanner sketch and see if we can find it now. Because it should have found an OLED as well. Should have found an OLED and it should have found an I2C. Because the OLED's plugged in. We didn't find anything. Let's try again now. It's found. It's weird, isn't it? Maybe I upset it. I may have upset it. Alright, it's writing. Okay, let's see if the scanner works. Right, here we go. Oh, it's not finding it. Unknown error at address. That's weird. Unknown error at address. Oh, I don't get that. We've got a weird one going on here. So, why is the scanner not working? How can I read the temperature off it? 1 minute, and then the next minute, and the time, and then the next minute it's right. Let's try this one again. Alright, we'll just upload that one again. Don't know, that's a weird one. Problem is you don't ChatGPT, don't know if the code ever worked in the first place. It has ideas on how to do stuff. It's not always. There might need to be a delay or something. Or pause in it. Anything might need to happen. Might be running too fast on an ESP32, I don't know. Or you might have to set the speed of the I2C bus and all that kind of stuff. Anyway, let's have a look. Right, let's reboot it. I've got a question mark. What's that? Oh. Hang on. Nothing found. Okay. Very strange. Well, I don't know. Let's just upload this code again. How can you get a temperature off it if it doesn't exist? I don't get it. If something doesn't exist, it won't give you a temperature. That I2C, the temperature is built into the chip. The same thing that reports the time. So there's a device there. Right, let's tell you what, let's try someone else's sketch then. Just make sure it still works. Right, so what mode are we in? I forget now. Yeah, still in access point mode. It's still working. And it's still reading the... Oh yeah, it won't find that. Because we need to be in a different mode. Let's change mode. Right, that'll reboot and then that'll connect in stage.
Engine 23 is now online.
Okay, we've got temperature. 26.3 degrees. So if we got that warm, if we made it hotter, how can you make it hotter or cooler? Put my thumb on it. Blow on it. Need some freezer spray, don't I? Anyway. Right, so, Right, let's browse for right, ESP32 precision real time clock sketch. Arduino. With sketch upload. No. Oh, it's not that. Hang on. RTC. Right, real clock explained. Internal, no. How to use internal RTC without an NTP. Right, okay. Right, okay, so this is the one we're using. Right, this is the one we're using. Trivial one, I'm still a newbie. Oh, still a newbie, right, okay. No, that's not what we want. Alright, what's this one? Yeah. Display on OLED. Oh, we could do that. Yeah, that's the one. That's the one. And yeah, we've got ESP, we've got an OLED. So has it got any code? We could just put that code in there. I don't need to know how to wire it up. Idea library. We don't need the library. We need the code. Yeah, we need. Here it is. Right, let's just get this. Start off by including necessary libraries. Right, okay. Right, let's just do this then. New one. New sketch. Right, let's just see if this will even work. Right, let's just do it. Compile it. These libraries should already be here already. These two. See what happens. Right, I'll switch over. Let's switch over to this one a minute. And grab a guitar. Oh my god, they're big, these guitars, aren't they? Oh my god. Right. I don't actually know how to play a guitar. It's not been tuned up in about 4 years. It's still close. Weird, isn't it? I'm still compiling anyway. You haven't missed nothing. Yeah, I haven't played that for a while. Anyway. Yeah, well, how many guitars I got? I don't know. Too many guitars. Too many. Can you have too many guitars? Still compiling, that is. Ooh. Oh, badly tuned. Hasn't been tuned for years. Right. What's the best guitar I've got? The best guitar I got. What is it? Oh, it's finished compiling now. Right, let's have a look then. Okay. Right. Ah. Port's busy. Right, hang on. Let's turn this port off. Right, it's finished compiling, so let's just upload it. Okay. It won't have to compile it again, it'll just bit quicker. The best guitar I got. Where is it? I'm gonna find that thing. What have I done with it? I'll dig it out because I really only need to keep one guitar and get rid of the rest. What's this doing? It's taking its time. Come on, you can do it. Right, it's writing. That's it. Okay, so this is a sketch that came off someone's demo sketch. Right, so okay, let's have a look. Reboot. Oh, something happening on the screen.
Engine 23 is offline. All engines are now offline.
Right, okay, so why is it doing serial when there's no data coming out of it? Couldn't find an RTC, okay. Right, I see. So it's only telling you it couldn't find it if it. Right, so what do you want is yeah. Anyway, what's on the screen? Let's have a quick look. Tell you what we'll do. We'll go on roaming shaky cam. Right, let's go on shaky cam. I'll show you what the display's doing. There you go. Oh god. What are these weird characters? Alright, let's turn it around. So I can see what it is it's doing. I know what it is. Let me change the settings for this. Put it back to default. Right, that's it. Can I open this up? Yeah. Oops. God, I forgot about a setting here. Oh well. Right. So what we got here? Let's have a look. Oh, I'm upside down. Right. Okay, so what we got? 20, 23, 6, 1. 16th to the 1st, 24, Tuesday, yeah. So it's definitely there, isn't it? Right. It's definitely there. So the old ChatGPT, it's leading me up a garden path, isn't it? Right, so let's make our own function then. So what begs the question, unless it's because it's been slowed down by doing the update on the display. 128 by 64. No, it's a 32 display I've got. 128 by 60, 32. I can't remember what it is. It's been a while. Right, anyway. So it's definitely there and working. So, begs the question. Oh, I've lost all ability to... Hang on. Right, that's the scanner. So why didn't that find anything? What's different about that? So we've got RTC. Right, that's different. Wire. Oh, that's a scanner. Hang on. Right, what's this one? R2D device is connected. Wire begin. Right, set up. It didn't do anything, did it? What did it do? Oh. Shenanigans. So that's using a different one. Oh, I don't know. Anyway, there's too many things, too many libraries, isn't there? So that one, it does work. We know it works. We consider display. Alright. Where do you go from here? Where do I go from here? I just want a function to check if it's there. Right, I'll tell you what I'll do. I'm going to unplug this. I'm going to put this one back on here. I'm going to reset the controller. Nothing happens. I'm going to unplug it now. Hang on, let me just put you back on this one. I'm going to unplug it. Right, it's unplugged. I'm going to reset the controller. Couldn't find an RTC. Check the circuit. Yeah, that's normal. That's what we want. So I'm going to plug it back in. Right, I'm going to restart it. Reset this thing. What's that say? RTC clock. Yeah. It's there. So I'll restart it. It says RTC clock on the display, but nothing on here. So why wouldn't they not? Why would they do? Where's it saying? Where's it getting that RTC clock from? There. So all we want to do is print that serial, print that. Why not just put that there as well? Just put RTC clock there, so you'll need it. Right, serial print RTC clock, that's it. Okay. Could write the time. Someone's code it. Right. Okay. Yeah, because if you can't find it, it'll just go into loop while one. It'll never be anything but one because there's no way to set it. Right, so let's just upload that. We'll make a function based off it somehow. Little. So it tells you the I2C address for the display, the OLED. And then this one, RTC, where's it gonna? Oh, it's just going to the default one, isn't it? Right, it's going to take a while. Yeah, it's all very boring stuff, but I suppose this is why a lot of people, they don't like to use ChatGPT. It's giving you code, in theory it should work, but in reality it doesn't actually work. It doesn't work right. For whatever reason. It's probably because lack of info. It tries to help you, but yeah. Right. Here we go. So we've got an RTC clock now. When I So we've got an RTC clock. Every time I reset the controller, I'll pull out the RTC clock. Reset the display's going nuts now. Couldn't find the RTC, couldn't find the RTC, check the circuit, plug it back in, reset it, RTC clock. Right, so that's a simple test, so we've got to make that into some kind of function now. Now is it going to find it if we take all the delay out? Right, so if we see, this is the 2-slot experiment all over again, where it shows you something different if you're not watching. Well, that doesn't make sense. But if you're not watching, it does something else. If you try to interact or watch it, So, yeah, by us putting a routine that prints out to the serial port, we're slowing it down, thus making it work. So what we need is... Well, the whole thing's slow anyway when it's running everything. God almighty. Right, so what I need is... yeah, so we need to find this where the RTC wasn't connected. Is it hanging us in the main code? Right, let's find it. Right, let's go back to this one. Right, let's find it. Where are we looking? I don't want that. That's not what we want. We want... Go back to main, go in RCD, go to definition. If not is running. Right, so we're not doing a great deal here, are we? We're not stuck in a while loop. We're literally doing... We've got our begin, and then if it's not running, then set it. But what we're not doing is we're not doing the other bit here. We're not doing if not RCC begin. That's it. That's what we're not doing. And we're just in the time anyway. Right. Okay. Right, so we get that over to our main piece of code. Why is it highlighting like this? I wanted to go to it. Right, let's just go into here. Where's init? I can't find it. Where is it? It is there. Yeah. Here it is. Right, so we need to alter this a bit. Let's just paste that in there a minute. Right. So we want to turn this into some code we can use. Right. Okay, so what we're going to do, RTC, if not RTC begin, right, okay, we need to include that here, so we're going to do if, I'll put it in here, if not RTC begin, right, so we've not begin, so if we've got an RTC, we're not going to wait, we're not going to do any of this, so we can get rid of all that now. So what we want to do is, if not RTC begin, Right, so if it's not begin, so it didn't, if it didn't begin, actually we need to, so we need to find out where that RTC begin is. Right, I think I've done something wrong here. Hang on, undo, 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 undo. What have I done? Have I lost it? Right, so RTC begin. Yeah, that's it there. Right. Yeah, so we need that code back again, right? But we only need that. That's all we need here, right? That's what we had before. That's what we got now, right? Okay. Right, so if not RTC begin, we'll get rid of that in a minute. We need to change that for that. If not RTC begin, then we need to right, so if it doesn't begin, then we need to do something else. Oh, yeah. So if not RTC begin, we'll do this. Else, we do this. Okay. We don't need that. That's the old one. Get rid of that. Right, get rid of that. Put this over here. Okay. So if it doesn't begin, do something. If it did begin, check if it was running. If it wasn't if it's not running, set it to be run or adjust it. Yeah. And then carry on. So the set time. Right, let's just have a look at that. Go to the definition. Right, so there's no point in doing any of that if, yeah. There's no point in doing that if it was unplugged. So what we need to do is, all right. I only set the clock like that instead, and not try to read from something that's not there. That's what will make it hang. So we need to, but that's always going to try and do that. So we need to alter that code slightly. Let's try, yeah, it's going to try to use it. Okay, so what we need is another little flag. Right, we need a flag. Okay. I wonder if you can keep asking if it began. Right. RTC begin. I need to find that. Go to definition. It's a boolean. Right, okay. True or false? Why it's going to keep trying to do that, isn't it? Yeah. Return if wire transition end transmission equals 0, return true, else return false. Right. Okay, I just need to remember that then. So we need it's a bool, so let's do a bool off it. Let's do a global variable. Right, okay, let's go to the top here. Let's create a new variable. Another byte, never to be used, never to be released ever again. 3 hours 23, never. Oh my god. This is not really a live stream that anyone wants to see again after, but don't know. Oh well, what can you do? What's that doing now? Right. Okay, so right. So we need a variable here somewhere. If try use, yeah. Okay. So we're going to try it. We're telling it it wants to try and use it without hanging. Does it matter? We're not hanging it anyway, but we're just trying to read from something that's not there. That's hanging it. So we don't want to read it if it's not there. Right, okay. So we need a bit of a flag going on here. But this same thing could be used elsewhere. Right, so what can we call it? Oh my god. Right, let's just call it alright, let's go in here. Go to the top and I just need to define something here. Okay. Right, so we're going to call it a bool. Precision real-time clock is connected. If precision real-time clock. Right. Not connected. I don't want to use that because it's like some kind of Wi-Fi thing. So what we need is anyway, I think we're going to end the stream there because it's going to go on and on and on and on. Oh, leave it running. I don't know. Right, bool precision. Right, so so we want the name of that, don't we? Let's just call it. Let's call it what it is. Hang on. Let's call it what it is. Here it is. Right. Let's call it what it is. Alright, so if it's if RTC right is connected. So go on to here. Where are we? Here. Right, so we've got that. Right, let's go to this. I'll go down to wherever that is. Where is it? Here it is. Right. If not RTC begin, then RTC is connected equals false. Well, it's false anyway, but we'll keep it there. Else, that's all of that. Right, so equals true. Right, so we've got, what was that? Got an extra space there. Oh, yeah. Right, so that's just going to set it running. Okay, I suppose we could have a whole load of state machines based on whether it's connected, whether it's running. Yeah, we do need a management thing at some point to tidy all this up. Right, anyway, so we've now got this, which we can go through to all the other stuff. And we need to find that, finding files, all that stuff. Oh, it's not finding it. Not finding it. Why not? Oh, here it is. Right. So get temperature. Go to definition. Right. So if it's that, do this. Right. Get the MCB. So Right. So we need to put a bit in here. So if is connected equals true, do this, else else do this. Alright, so if it's that, do this, or do that. Right, okay. What else we got? Let's go down the list here. Alright, let's go down here. So we've got that sorted there. We're going to use it there to include this. It includes these, but it won't execute them. Get the temperature. Yeah, that's going to do that. Okay. Set the time. Right, so we don't want to try and set the time unless it's connected. So we do another if there. Right, okay. If it's connected, we'll get the time. If not, we want to do else. I want to do this one. Okay. Right. Any others? Any others? Oh, that one. Right, if set time, get the temperature, set the time, Arduino Omega. I suppose we could adjust that to do the same thing, but then my Arduino Omegas are soldered in, so they're always connected. Right, is that going to be enough or not? No, there's a bit somewhere else on command, wasn't there? Right at the top of command here. Yeah. So, but we've already done it in get temperature. I might as well do it here. Right. Right, if it's got it, get the temperature. We've got something weird going on here. We go to. They're already checking it here anyway. So it doesn't really matter. So this is. There's no point in putting this here. And there's no point in doing that because we're going to check the temperature on whichever one all this can go, really. Yeah, all this can go. So we just need to get temperature. It's already going to return that anyway. As long as we're sure. So it just can get the temperature and it's already doing the checks down here. It's already returning 0 and yeah, we don't need all that there. So yeah, so we just need to get the temperature. Let's just do it. I'll simplify it a bit anyway. Yeah, that's it. We've done it. We've simplified it a bit there. Right, okay. I think that's it then. Right, let's try and compile that. Let's make sure we've closed any Arduino. Yeah, we've got nothing there, so okay. Right, let's compile and get the guitar out. Play a guitar, practice a guitar while we're waiting. Ooh, been a long time. I should play a bit more often. Anyway, play it a bit more often. Oh, get the keyboard out. Got a guitar somewhere. There's probably no batteries in it though. I'll took them out to something. I better left them in. Alright, still compiling. Where's my guitar? What do I do with it? There it is. Extraction. connection. Extracting the guitar. Right, what's this got? Any batteries in it? No. If there is, oh no, all batteries are gone. Oh, one battery missing. So I took it out, obviously took the battery out to keep the batteries from going flat. Oh, Yamaha guitar. I'll have to play that. It's actually not that bad, that one. Right, it's finished compiling, so let's have a look. Let's press the button, upload it. Oh, it's getting cold now, dropping cold. What's the temperature? What's that say? Feels what? 1 degree? Never. 1 degree. It's 1 degree in UK. 1 degree. It's 1 degree in the UK. Oh, broke out in song then. Oh my god. You know, my uncle used to write songs. He's passed on now, but when I was 12, I used to he had an accordion and he used to write songs.
Engine 23 is now
Right, so
online.
what's happened here then? So we've got okay, we've got non-blocking. Hopefully we won't have a blocking. Let's get this up on the screen. Okay, so we've got communication, so right, we're in station mode. Let's just bring that up. So if we have a look, we're in station mode and we're talking to it. So we want to try it in access point mode. So tell you what we'll do. We'll get a little bit more excited. What we'll do is we'll put this in here. I'm just setting up our camera. Alright, so you got camera and you can point it with an angle. I think, can you? Oh, maybe not. Thought you could. Yes, you could alter the angle. Anyway, let's switch it on a minute. Right, hang on. You want this one? And star camera. And we want to turn it round so we can see the display. Then we want to focus it. I always go the wrong way when I focus it. Right, so you can just about see January. Why can't I zoom right in? Anyway, right, so I've got it there. Bit better view than the other view. Can hardly see it. Oh, tell you what, I've got an idea. Right, I've got an idea. Alright. Oh my god, hand to eye coordination's rubbish on this thing. What we got there? Right, can that be focused? Let's see if I can focus that. Oh my god, my hand's going the wrong way. What is it with me and hand to eye coordination? Hang on. Oh my god. Hang on. Right. What? Why can't you see it? I need to sort out a macro lens something or other. This one's out of date, yeah. Right. You can just about see 16th of January 84. Just about see it. Right, so we're going to put it into access point mode now. Alright, it's going to reboot. Right, and it's got past the lockout, so it hasn't locked itself out. And it's read the real-time clock, 16th of Jan, and it's ticking. Right, so we're no longer in this mode here. It's stopped.
Engine 23 is offline. All engines are now offline.
Yeah, it's offline. Alright, so we've got the time. Now, begs the question now, can we set the timer? I'm going to put that down. Let me try and get this. Tell you what we could do. Hang on, let's have a juggle. Yeah, let's have a juggle. So let's move that out the way, and we'll unclamp this. Alright, unclamp that. Oops, I'm smashing the microphones here, sorry. Right, let's put this down here, and oops, oh my god. Right, let's put that back over there. Let's right, let's shift that over there. Right, okay, let's bring it round. Something like that, so we can see it. And try and tighten it. Focus it. Clean the display. Right, so we've got, there we go. It's a bit bright in it, hang on. Does altering the, no, I'll leave it like that. Right, you can see it a bit. Okay, so right, let's bring up the connect to it on the phone with the straight to the access point. We'll connect to it. We'll alter the what we're going to alter. Forgot now. Alter the time zone. Right, we're connected. Right, I'm actually connected now. Let's just bring you back to this front view, mate. We're connected. What's going on? Why is it get a glare off it? Yeah, 16th of January. The MD mode is access point, and it's sending me the date and time. Alright, so what I'm going to do now is I'm going to log in, go to the timer, and put you on this view here. See, hang on, There's only way I can put you on the other view so you can see the relay as well. Hang on, can I bring it over a bit? Where's the relay? Yeah, what have I done? Oh, I need to back it off a bit. Right, let me just back it off a bit. I can see a bit more than just the screen. Right, so you can see now. Also see you can see the LED and the display. Yeah, right. So the LED's up here somewhere. Okay, right. I've got to connect to it now. It's saying it's 2349, 2350. We're on Wednesday. Is it Wednesday yet? No, Tuesday. So I'll go on to Tuesday date and choose 2345, 2345 and off at 000. Well, will that work? I don't know. So let's set it. Ready? Here we go. No. No, because that's the last segment in the day. So 23. So 23. Let's say 30 till off at. We've got a bit of a time here. That's off at 23. Maybe that'll work. 23:45. Right, save. That hasn't saved it. Didn't like the because we're on the last digit before it finishes. It's already past the time. Yeah. So it's found a bit of a weird thing, isn't it? Let's just try something for. Right, let's try something. So 23, 45, and it's gonna go off at 1 o'clock in the morning. Let's try that. Don't know what that'll do. Nah, doesn't like it because it wants to, the way it works is it wants to see a start time before the end time, because that's on a new day, isn't it? It's basically at 0 o'clock or 1 o'clock, 12 o'clock at night. It goes on to the next day. So you could make it go on all the time. So 23 to 23:45. No, let's not put it in. Hang on, did I choose Tuesday? Tuesday, 23 to 23:45. Save. Yeah, it's updated the time, but because we're already on the off time, so I'll have to do Wednesday now. Wednesday at 0 to 1/4. Save. No. On at 23. Right, yeah, that's confused it. So what I haven't allowed for is when it gets near the last 15-minute segment, of the day. We need to sort that out. But it's not a time people want something to happen normally, but I mean that's beside the point. Alright, so I needed to treat it. It needs to know that 00 is midnight rather than the start of a new day. But it's also start of a new day. Anyway, so the clock is set. So I'm happy about that. I've got other things to sort out. Right, let's put it back onto normal mode now. And it'll reboot and... Alright, we've put it back onto normal.
Engine 23 is now online.
Right, I think we're gonna call it a day there. Getting cold now. Cold and hungry. Oh dear. Right, yeah, that's gonna be about it for today. So what have we done today? We've just shut UPAS down. Oh, your temperature's working. So we've got temperature working. We've managed to plug in this gadget here. Let's go on to the other view. And we've managed to plug in a real-time clock on an ESP32, which is nothing to write home about. It was doing this years ago, but it's combined with an NTP server, and this is precision real-time clocks for when you're in access point mode, so we can still have our timers on and stuff without an NTP server. So if it's out in a field, it still knows the date and time. You can use it for all sorts of stuff, event login, data login, or time zone, built-in timer to do something at a certain time. If you want to water your flowers or something. Yeah, all that kind of stuff. Right, okay. We've got the temperature working as well, which we didn't have working before on this particular engine, this model. So we can do stuff with the temperature now. I haven't seen it move hardly. It's pretty constant, 26.8. Yeah, it was a bit lower to start with. Hasn't really altered. Anyway, this is going to be about it for now.
Thank you for using UPAS.
Thank you for watching. Anyway, this one's a bit of a 3-4 hours worth of just if and buts and maybes. Oh well. Right, I'm going to commit this. Precision real-time clock and temp on ESP32. Okay. Right, yeah. That's gonna be it for now. I'll carry on another day. So, yeah, we're back on here, so we can get back on here. Yeah. So what I was doing, I was in the timer bit here, adjusting this here. Trying to get it to trigger on the last 15-minute segment of the day, but I couldn't get it to do that. Okay. Well, I'll have to look at the program, but to be fair, I only want it in the day really, but I mean that doesn't matter. Needs to be able to either do it or so we need to have a look at that. Right, that's gonna be it for now. Thanks for watching. Oh, hang on, let me get you on this one. That's gonna be it for now. Thanks for watching. And I'll see you all on the next one. Hopefully it will be might be a bit fresher that day. See you in a bit. Thanks for watching. Bye bye.